Hey there, hope you had a great day today. We're going to talk about some properties of logs. These properties are going to allow us to expand and simplify. And in the beginning, it's going to seem like, why do we do this? But as we get into the solving and you start seeing how these properties appear, you'll appreciate their value. So we're going to talk about the product property of expanding, product property, the quotient property, and the power property. We're also going to look at, and as a matter of fact, we're going to do this first, we're going to look at some identity properties. So the identities are what happens when the base and the input are the same. The base and the input are the same. And then how do I use these properties to expand a log? So let's get started on these properties. The zero property of logs. We've talked about this. Log base b of the input 1 equals 0. This stems from the fact that 1, the input 1, is going to equal b to the 0, and we know that any base raised to the 0 power, we know for sure that that's 1. The positive identity property of logs, I break them out into two, positive and negative, but the negative just stems right out of the positive, so you don't often see them as two different properties. You just see them as the identity property. But anytime your base of your log and the value of your input are identical, then it's always going to simplify to the number 1. All right. And this stems from my input b has to equal my base b, this is exponentiation, raised to the power of 1. And we know that b to the first equals b all the time. And then likewise for what I call the negative identity property, if my input 1 over b, that had better equal my base of my log b raised to my exponent, and we know that those are true. Okay? The inverse property of logs says that anytime my base and my input have the same value, but if my input is raised to a power, it just simplifies to that power. It actually stems from the power property we're going to talk about in just a minute, and the identity property. Basically, what we're going to learn in just a second is that this x gets to move to the front of the log. And then from here, you see that log base b of the input b is 1, so then I get x times 1, and that equals x. Okay? And then the inverse property for exponentials is very same. This is the idea behind exponentiating, and that just plays out. So the base b raised to a log of the same base b with an input of x equals x. So expanding properties of logs, there's 3 of them. The first one we're going to talk about is the product property. And notice what's happening is that my input is the product of factors, in this case m times n. So if my input is a product of factors, then I can expand this log to be the sum of those two logs, log base b of m plus log base b of n. It stems out of when you exponentiate, or within an exponent position, if you multiply like bases, then you add the exponents, okay? So log base 4 of 5x, this is really 5 times x. Those are being multiplied together, so I get log base 4 of 5 plus log base 4 of x. The log base 3 of xyz is log base 3 of x, and then we're just expanding it to 3 factors, plus log base 3 of y plus log base 3 of z, just like that. Okay? Number 3, it looks like it's only 2 factors, but really there's 4 factors there. It's 3 times y times 2 times x. So we're just going to expand this to 4 terms. Log base 10 of 3 plus log base 10 of y plus log base 10 of 2 plus log base 10 of x. All right. Now I want you to try the video question and write down any questions if you get it wrong. All right. The next property we're going to look at is called the quotient property. And basically it says that if your input on your log is a fraction or what we call a quotient, then what we can do is we can subtract those 2 logs. So think about what we did when we were simplifying exponents. If our bases were the same and one was in the numerator and one was in the denominator, we subtracted our exponents. Remember, the answer to a log is an exponent, so we can subtract these 2 logs, okay? So this can be written as log base 3 of the input x minus log base 3 of the input z. Okay. Number 2 is log base 4 of the number 5 minus log base 4 of the input x. Try the video question and then come on back. The last property that we're going to talk about is called the power property. And it says if the input of a log is raised to a power. So notice what you have here. See how this n is in the exponent position, okay? Then the log can be expanded to the power times the log. It moves from the exponent position to the coefficient, okay? The power is moved to the coefficient position of the log and then is multiplied by the log, okay? So you move it in front to the coefficient and then you multiply it, all right? So let's try a couple here. Log base 4 of x to the 5th. I'm going to move that out front, so I get 5 log base 4 of the input x. Okay. Number 2, you can do this 2 different ways. I'm going to move it, I'm going to apply it to each of these values and then I'm going to move it. So this is log base 3 of 2 squared x squared. And now I'm going to expand log base 3 of 2 squared plus log base 3 of x squared. And so it gives me 2 log base 3 of 2 plus 2 log base 3 of the input x. Okay. Number 3 is a little bit easier. And this becomes 2x times log base 10 of the input 3. So why don't you try your video question and then come on back. All right, we're going to move into expanding, all right, with multiple properties being used. And so I'm going to give you just some hints, okay? And I know there's a lot on this page, but if you see something in a radical form, convert it to rational. Apply your powers to powers before using the product or the quotient property. I think you'll get more consistent results. Apply the product and quotient property in the order that they appear. If there's more than one factor in the denominator, remember to subtract all of them, not just the first one. A negative exponent can be moved to the front just like a positive exponent. Pay attention to its location, because if it's in the denominator with a negative exponent, you're going to have that double negative effect. And then watch for the number inputs values that simplify to 1. Watch for those properties that we talked about on slide 2. Okay, so expand each log and simplify where possible. Okay, so the first thing I'm going to do is I'm going to write this as x to the 1/2. So this is log base 2 times x to the 1/2. Now I'm going to move use my power property, and I'm going to get 1/2 times log base 2 of the input x, and now I've expanded it. Number 2, notice that I have things being multiplied together, inputs being multiplied together, and inputs being divided. So I'm going to break it up using my power or my product and quotient property, and then I'm going to apply my power property. So this is log base 10 of a squared plus log base 10 of b cubed minus log base 10 of c to the 4th. Okay, now I'm going to use my power property to expand. This is 2 times log base 10 of a plus 3 times log base 10 of b minus 4 times log base 10 of c. Okay. On number 3, I have log base 10 of 10 times, and in parentheses, u to the negative 2, n to the negative 2. So what I'm going to do here is I'm going to apply this outer exponent first, okay, before I expand. And I'm going to get log base 10 of 10 times u to the 4th, n to the negative 2. Now I'm going to bust it apart. So I have log base 10 of 10 plus log base 10 of 4 log base 10 of u minus 2 log base 10 of n. Now I'm going to look for any kind of identity, and look, I have log base 10 of 10, so that's 1. And there's your final answer. I've saved this slide for your video questions, so go ahead and work them, and then come back and I'll work them with you. All right, here we go. I'm going to get rid of my radical, so I have log base 4 of 5 times a to the 1/3. Now I'm going to use my product property, and I'm going to split everything up, so I get log base 4 of 5 plus log base 4 of a to the 1/3. Now I'm going to move my powers down, so I get log base 4, that looked like a 4, of the input 5 plus 1/3 log base 4 of a, and I'm done. On number 5, I'm going to apply this property first, this exponent, before I split, and I get log base 7 of x squared over y to the 12th. Now I'm going to use my quotient property. I'm going to go out to the right here, and I'm going to get log base 7 of x squared minus log base 7 of y to the 12th. And now I'm going to apply my power property, and I'm going to get 2 times log base 7 of x minus 12 times log base 7 of y. And now I'm done. The final video question, I'm going to apply this to each of those inputs, and I get log base 8 of 2 cubed x cubed. Now I'm going to expand log base 8 of 2 cubed plus log base 8 of the input x cubed. Okay, now here's where just a little experience comes in. Notice that 2 cubed is 8. So instead of bringing my 3 down, I'm going to write this as log base 8 of the number 8 plus log base 8. This one I'm going to bring down, plus 3 log base 8 of x. This log base 8 of 8, that's 1. And then you get log base 1 plus 3 times log base 8 of x. Okay? All right. This is the daily assignment. If you feel like you need to have a little bit more practice, please try a couple of them. If you want to go through how the properties work, I encourage you to look at slides 10, 11, and 12 and come with any questions. Thanks.